So think back to the early days of blockchain smart contracts. Really powerful stuff, but, they had this big limitation.
Yeah, they were sort of operating in a bubble, weren't they?
Totally isolated. They couldn't easily connect with the real world, couldn't get data from outside their own digital space.
It's like having a super smart program that can't actually see or hear anything outside its own code.
Exactly. A brilliant scientist with no lab equipment, like I was thinking earlier.
Mm-hmm. And that isolation, it was a real challenge because smart contracts, they need to act based on certain conditions, right?
Right.
But what if those conditions depend on, say, the price of oil or, I don't know, the weather, things outside the blockchain?
The contract just stops, hits a wall.
Precisely. Which brings us nicely to our topic today.
WINkLink, we're doing a deep dive into this decentralized Oracle project. It's built on the TRON network.
And that word oracle, it sounds maybe a bit complex, but really it's just a bridge.
A connector, yeah. A way for those isolated smart contracts to securely get data from the outside world.
And we're basing this discussion today on the official WINkLink developer documentation. Going straight to the source.
Yep. Our goal is really to unpack how WINkLink works, make it understandable, and show why it's, well, pretty important, especially with DeFi blowing up.
Definitely. That whole world of decentralized applications really needs this kind of connection.
Okay, so let's dig into that bottleneck again. Why was it such a big deal that smart contracts couldn't get external data? What couldn't they do?
Well, think about decentralized betting, for instance. You need to know who won the game, right? The smart contract can't just guess.
It needs a reliable source for the final score.
Exactly. Or stable coins, the crypto coins pegged to, say, the US dollar.
Sure.
Smart contract managing that needs real-time, accurate price info all the time.
Makes sense.
Even things like decentralized insurance, maybe covering flight delays. The contract has to know for sure if the flight was actually delayed.
Right. It needs external proof.
Without that link to outside data, these more useful, more complex dApps, they just couldn't work properly. Not in that trustless, automatic way blockchain promises.
Okay, so the Oracle comes in to fix this. It's the messenger, the data bridge.
That's the idea, that plays that vital intermediary role. But, and this is a big but, the first attempts often use centralized oracles.
Yeah. And that sounds like it brings back old problems, right? Like a single point of failure.
You got it. That's the core issue. If one single company or server is feeding the data,
it kind of defeats the purpose of decentralization, doesn't it?
totally, that central oracle, it could be hacked or manipulated, or it could just crash.
And then every smart contract relying on it is suddenly blind or getting bad info.
Exactly. It undermines the whole point, that trustless, censorship-resistant system everyone's trying to build.
Okay, that really clarifies why decentralized oracles are the way to go, which leads us right back to WINkLink. So it's a decentralized solution.
Correct. WINkLink is specifically designed as a decentralized oracle network. And like you said, it operates on the TRON blockchain.
And for listeners wanting more background on TRON itself, the docs point to the TRON Developer Hub, right?
They do, yeah. It's a good resource. But WINkLink's core job, its main function, is providing that secure, reliable data feed for TRON smart contracts, connecting them to the real world without that central point of failure.
And you mentioned DeFi on TRON is growing, so the need for this is increasing.
Definitely. The documentation highlights that. As more complex financial applications get built on TRON, they absolutely need stable, trustworthy, decentralized data sources. WINkLink aims to be that source.
All right, so we get the why. Let's get into the how. How does WINkLink actually work? The docs talk about a node model. Can you break that down?
Sure. So the node structure has three main pieces. First up, the external data source.
Okay, what's that involve?
Pretty much anything outside the blockchain that has data. Could be crypto exchanges, other Oracle networks, stock market APIs, weather stations, you name it. Yeah. It's about variety.
So getting data from lots of places, what's the second piece?
That's the WINkLink node itself. This is like the engine room.
Okay.
Its job is to basically run tasks. It watches the TRON blockchain for requests specifically. It listens for certain events from smart contracts.
So it's listening for a signal like, hey, I need data.
Exactly. When it hears that signal, it goes out to those external sources, grabs the needed data, maybe processes it a bit, and then sends the result back onto the TRON blockchain.
Got it. It's the retriever and the deliverer, and it speaks blockchain. And the third part is the TRON blockchain.
Right. The TRON blockchain isn't just passive here. It provides the communication tools the WINkLink node needs. The docs mention the full node API and the event API.
APIs, so ways to communicate.
Yeah, think of them as specific phone lines. The event API is how the node listens for those requests we mentioned. The full node API lets it interact more broadly, like checking balances or sending transactions. So the blockchain lets the node monitor contracts, trigger its own tasks, sign the data it sends back, and actually deliver that data to the right smart contract, the consumer contract that asked for it.
So that's the two-way street. The node listens to the blockchain via events and sends data back to the blockchain via transactions.
You've got it. It's a constant back and forth driven by the needs of the smart contracts.
Okay. Now, the docs also briefly mention a request model, something about how those requests are created.
Yeah, they touch on that. It seems to detail the specific steps for how a contract makes a request and how it's processed. The docs say there's more detail there, but for this overview, the node model gives us the main picture.
Understood. Keeps it manageable for now. But then there's this other thing, WINkLink off-chain reporting, OCR. Sounds like an upgrade.
It does, yeah. OCR is described as a newer approach for aggregating data within the WINkLink network.
Aggregating, like bringing it all together.
Exactly. And the goals are better scalability, handling more requests, more stability, and pushing decentralization even further. The docs call it promising.
Okay, interesting. How does that work differently? Off-chain, does that mean less happens on the blockchain?
Sort of. With OCR, the WINkLink nodes talk directly to each other, peer-to-peer, P2P.
Okay.
They form a little network among themselves. One node gets chosen as a leader, the others are followers, and they have a lightweight way of agreeing on things amongst themselves off the main chain.
A leader and followers coordinating off-chain. So how does the final data get onto the blockchain?
Right, so each node participating still gets the data independently. Then, critically, it digitally signs its own finding, like saying, I vouch for this data.
Okay, individual verification.
Then they send these signed reports to the leader node. The leader collects them all, bundles them into one big report.
A combined report.
Yes, and if enough nodes have agreed, if certain conditions are met, the leader sends this single aggregated report to the TRON blockchain, just one transaction.
One transaction instead of, what, dozens of separate ones?
Potentially, yeah. That's the efficiency game. It drastically cuts down on gas costs, the transaction fees.
That sounds like a big deal for keeping costs down.
It really is. And that single transaction, it still contains the combined report, proof that a minimum number of oracles, a quorum, signed off, and all their individual observations.
So the verification is still there, just packaged differently.
Exactly. The trust isn't lost. When that single transaction hits the blockchain, the chain itself can still check the signatures from the quorum. It verifies everything on-chain. It's a quite clever system.
Efficient but still secure.
That's the goal. But it's important, the docs do mention OCR is still in beta testing. So, it's evolving. More info will come out as it stabilizes.
Good to know. So, okay, for a developer listening, maybe building a dApp on TRON, how do they actually use WINkLink?
The documentation points to two main services right now. If you need asset prices, like for a DeFi app,
Like the stablecoin example.
right, there's the price feed service. And if your application needs randomness, like for a game or a lottery, but needs it to be secure and provably fair.
Can't just use a regular random number generator.
No, you need something verifiable on-chain. For that, there's the Verifiable Random Function Service, or VRF. Those seem to be the main entry points for developers.
Price feeds and VRF. Got it. And if people want to learn more, maybe get involved with the community.
Yeah, the docs list a few places. There's a WINkLink Telegram channel for chat and help.
Okay.
The code itself is on GitHub, if you want to look under the hood.
For the technically minded.
And they provide a developer email address, too, for specific technical questions. So plenty of ways to engage.
Great. All right, so let's try and wrap this up. Our deep dive into WINkLink, it really seems like it's tackling a fundamental blockchain problem.
Absolutely. That core issue of smart contracts being isolated, WINkLink provides a decentralized bridge to the real world, specifically for the TRON network.
And being decentralized is key, avoiding those single points of failure we talked about.
Crucial. It makes the whole ecosystem, especially DeFi apps on TRON, much more reliable and trustworthy.
And that off-chain reporting, the OCR, that sounds like a really interesting step towards making it all work even better, more efficiently.
Definitely one to watch as it moves out of beta. It shows they're focused on scaling and improving.
So for you, the listener, think about this. What happens when dApps can securely, reliably pull in any kind of real-world data? What does that unlock?
Yeah, what new kinds of applications become possible? Things we maybe haven't even thought of yet.
And as WINkLink keeps developing OCR, how could that change the game for decentralized data, not just on Tron, but maybe as a model for other systems too?
How does it impact trust online when you have these verifiable, decentralized data feeds becoming more widespread?
Lots to think about there. Definitely some fascinating potential.